Okay, just a few more things to share with you about dividing a polynomial divided by a polynomial. So this is still Chapter 1, Section 9. I would like to do this particular problem. It's got nothing unusual about it, just a reminder from the video prior to this. So when I divide by 3x minus 1, I'm looking to put a term up here that when I multiply it by 3x, I'm going to go ahead and get rid of that. When I multiply that by 3x, I'll get 6x squared. So I need a 2x up here because the 2x times 3x, again, I'm going to write it over here. I'm taking the 2x and I'm multiplying it by the divisor, the 3x minus 1, and I'm putting that expression right here under these two terms. So here I have 6x squared, and then 2x times a minus 1 is a minus 2x. And remember, now I'm going to subtract, so I'm going to change this sign and change this sign. These terms will always add to be nothing because you forced them to be alike. So when you subtract them, they'll add to be 0. And 7x and 2x is going to add to be 9x. Here we go, 9x. And then bring down the minus 3. And let's start that process again. So I need a 3 up here because when I multiply it by 3x, I'll get 9x. And when I take this 3 and multiply it by a negative 1, I'll get a negative 3. And this one happened to, again, have a remainder of 0 because when I change the signs to subtract, I get 0 as a remainder. So my answer is 2x plus 3. All right, let's go on to a couple of harder problems. So when the polynomial that I'm dividing by this divisor of 2x plus 1 is not in descending order of the exponent. So it's not written, if you will, in proper form. What you need to do is you need to rearrange it. So you need to put the 6x cubed term first, then the x squared term, which had a minus sign in front of it. And you see that there's just a 1 here. There's an x cubed, there's an x to the second, but there's not just a plain old x. What I like to do is put in light color, so I like to use this light green, a 0x term because there is no x term. And then finally I'm going to bring this 1 over, and I've got this quotient divided by the 2x plus 1 right here. I'm rearranging that as well, so I'm writing that in descending order. So it's the 2x plus 1. Once you've done that, then things are going to fall into place just nicely. So I'm looking for now a term that I'm going to put right here that when I multiply by 2x, I get 6x to the third power. So 2 times 3 will give me the 6, and x times x squared will give me x to the third. So again, I'm taking this 3x squared times this whole binomial. So the 3x squared times the whole 2x plus 1. And that result is going to go right over here. So this is the 6x cubed. This is a positive 3x squared. Because I want to subtract now, I'm going to change these signs. So this one's going to become a minus. I like to make it nice and bold when it's a plus here and I want it to become a minus. This is a minus 1 x squared and a minus 3 x squared for a total of a minus 4 x squared. But I'm going to do that in black. So a minus 4x squared. And then I'm going to bring down the 0x just in case an x term shows up in my next round. So see this minus 4x squared? And I've got a 2 here, x. I need to multiply that by a minus 2x in order to get the minus 4x squared. So again, a minus 2x times the 2x plus 1, the divisor. That will give me this minus 4x squared. And this minus 2x times 1 is a minus 2x. And now I've got to subtract. So I'm going to change my signs. This one's positive. Now this one becomes positive. And notice it was helpful for me to put the 0x here because when I add 2x to it, I get 2x, and now I get to bring down that positive 1. See this divisor of 2x plus 1 and this 2x plus 1? And for that matter, I just need to multiply a 1 by this 2x plus 1 in order to get this. And then I'm going to change my signs because I'm subtracting. And this one again has a remainder of 0. The answer is the 3x squared minus 2x plus 1. The one thing I would like to mention to you is any of these problems can be checked by taking your answer times the divisor and then adding the remainder in order to get this 6x cubed minus the x squared plus 1. So if you took your answer of 2x plus, I'm sorry, that's your divisor, and multiplied it by your answer, you would get, if you multiplied this all out, you would get the 6x cubed minus the x squared plus the 1. Now, if there had been a remainder, you would just have added the remainder or subtracted the remainder. I was trying to erase that. So added or subtracted that remainder, and you would have gotten this result as well. All right, let's just do a couple more. This next one is pretty challenging, and that's because it's an x cubed minus an 8. So I'm going to leave space for an x squared term and an x term. And then I'm going to put the minus 8. So if I want to divide that by x minus 2, that's how I'm going to write that out. Again, these aren't necessary to write them, but you just have to make sure that you don't try combining terms that are not like terms. So I'm going to come on up here and I'm going to put an x squared here because x squared times x is x to the third power. And then this x squared times a minus 2 is a minus 2x squared. So again, I wanted to line this up under this nothing right here, not under the 8. I wouldn't have wanted the 8 to be over here to try to combine it with a 2x squared. Again, remember you subtract, so you change the signs, and we're going to bring down 2x squared because 0x squared and 2x squared is 2x squared. We'll bring down, you can bring everything down. You can bring the 8 down if you wanted. But now, because of this 2x squared here and that x right there, I've got to multiply by 2x in order to get this 2x squared. And then this 2x times a negative 2 is a minus 4x. And then again, going to subtract. So change my signs. X squared terms disappear. 0x and 4x adds to be 4x. Now I'll bring down my minus 8 and I'll use it. I'll need a 4 up here so that when I multiply it by the x, I get 4x. And then this 4 times this minus 2 is a minus 8. And then finally, change the signs in every step and a remainder of 0. So here's my answer. X squared plus 2x plus 4. By division, show that x cubed plus y cubed divided by x plus y is not this answer. And you can see why some people would think maybe it is. They'd think that you could put the x cubed over the x and the y cubed over the y and get x squared plus y squared. But that was only when this was a monomial, not when it's a binomial. So you have to use or think about long division. I must say that there's also a process of factoring the numerators and factoring the denominators to simplify these, but it's only if the remainders are 0 that they will work. So let's go ahead and take x cubed, and I'm going to see how many spaces I need for this problem. I'm just going to put the y cubed way over here because I'm just not sure how it's going to turn out. So I'm going to divide it by x plus y. So I'll need an x squared right here because x squared times x will give me the x cubed. So that right there is x cubed. Here I'm going to have a positive x squared y, and then I'll go ahead and change my signs. So there's nothing here to add to this, so I'm just going to bring it down as a negative x squared y. Again, it didn't combine with y cubed. I need now a negative x, because this negative x times x will give me the negative x squared y. I'm sorry, I don't need just an x, I need an xy here. So I'm going to see if I can erase this. So there we go. There we go. So I needed a minus xy, so that when I distribute that by the divisor x plus y, right here I'd get a minus x squared y, and those would match exactly. But then right here I'll have a minus x y squared. And so now, again, I've got to change my signs here and here. And then these disappear. I'll bring down my x y squared. Let's see. I've got an x up here, so I'm going to need a y squared here in order to multiply the y squared by the divisor of x plus y and get this x y squared. But when I multiply y squared by y, I get y cubed. Oh, that means maybe I should now bring this one down, because those are like terms. So now I'm going to subtract. So I will change the sign and change the sign, and I have a remainder of 0. And I have my solution to this problem. It is not x squared plus y squared. It's x squared minus xy plus y squared. We just completed dividing monomials by monomials, polynomials by monomials, and then poly divided by poly, which was the focus of this particular video.